Good morning everyone and welcome back to our tutorials on using ShopTurn. Alright, now we will make some videos where we will look at the various functions of ShopTurn individually. So we won't be starting from a drawing anymore, but from a raw material that will be more or less with standard measurements like 100x 200, and we will be looking at the soft keys within ShopTurn. What do they allow us to do? What operations can we perform on this raw material? So let's start with a program that we will call example, where there's already a raw material that we will size according to our needs. So let's set 100 as a par reference point. All right, a cylinder that will have a diameter of 100, corner and excess material of 2 mm. A length of the raw material of 250 minus coinzimi, and a projection of 200 meters. Unclamping, simple. All these things are the same as I explained to you before. Here we put the minus because otherwise it gets messy. They are the same things I explained in the previous tutorials. We accept it. Now we have a simple program where we define the raw material. You see that here we have some soft keys that allow us to perform various operations. Drilling, turning, profiling, and milling. We don't go in order, but we go to see how we can work point by point. So with this soft key, we go to the last one called line circle. Let's start with the standardized operations. That is turning. You see that we have roughing, groove, discharge, thread, and cutoff. Roughing involves turning of profiles, let's say predefined. So it could be the hollowing out of an area, an area with rounded, sloped, or beveled parts, or the hollowing out of a sloped area. The first thing we need to do, of course, is select the tool. I have completely emptied my table. Tool. So at this point, ShopTurn tells us, look, I can't work without a tool. So we click on the position where we want to install our roughing tool, and we're going to tell it to either select from the inventory, let's pause, or list of tools. And here it shows me a list of the tools that it places at the bottom, let's say, of our positions. Tool holders. Perfect, new tool. The new tool, on the other hand, takes me to all the preloadable tools via the ShopTurn. So we can start with a roughing tool. As you can see, we have the option to choose it. Let's say traditional external pull in traditional, internal pull in traditional, and then with the arrows in other positions. So the roughing frame, what else? Do we want to rough with a CNMG? So we select this one first and click OK. Roughing tool, roughing utilities. So the machine is asking me for a name, so potential roughing. We add a CNMG. You can obviously add whatever you want. The radius of the insert, which is essential 0 point, length X and Z. The machine will choose them when you go to set the zeros. Tools 95, so the angle between the attachment and the tool shoulder. I'll give you an example. You see, if I set it to 80, what happens? Okay, you see 80 degrees, but actually we set it to 95 and 80 degrees. Instead, it's the angle of the insert. That is, if you want, you can put in the shape, and you'll start to see a DNMG. The inscribed radius inside the insert. The rotation sense of the self-centering tool, and whether you want to use or not use water or even high pressure. It transfers to the program, and here it inserts the roughing tool. With an F and an S, let's say standardized, then you can go on the F table and write 0.3, like millimeters per revolution for roughing at 2000 RPM or meters per minute. Whether it's roughing or machining, I want to do a roughing or a finishing, even though he called it roughing. You can choose well. Here I want to do a roughing. I want to do a longitudinal roughing that involves a hollowing out. You see that when you move, it changes your life. It completely empties the table. Let's start by hollowing out. Let's select the tool. This one is good. Look at the params. Cutting, don't 3. While per minute is just fine. Machining, now roughing. Here you can choose whether it's an internal roughing. If a roughing external in a pull, rather than if it's the classic standard roughing, let's say, of a cylindrical piece on the outside in the longitudinal X. Type of machining. I want to work along the Z-axis or along the X-axis. Normally you work along the Z-axis. Then the starting X is set to the external diameter of the rough. If we want to be safe, we gave it an external diameter of the rough piece 100, averaging about 102. So that any oversizing doesn't create issues for us. For 0, starting point, we can set it to 0. Keep in mind that we have already set some safety points in the rough piece. And here we have either the depth of material to be removed, either leaving it incremental or setting the absolute diameter at which we want to rough the piece. The length at which we want to rough the diameter, the depth of the pass. So 5 mm UX and Us are the possible Sora metals accepting and simulating us. Let's see what we've done. You see, if you want to see it in 3D, press 3D. And you have exactly the work done. You press the button and it goes back to the program. You press the arrow key and it will be modified if you want to change something. Obviously at this point, if you want, you can use one of the other 3 roughings. You have to cancel it. And you can use the trim button and go back to turning. Roughing. Sorry, you need to position yourself here for roughing and select one of these 2, providing the parameters you need. Did you notice that you can create radii or chamfers? Just press the left soft key. This could be the previous operation simply with chamfers or radii on the entry and exit, or you can also perform a conical operation. Okay, it's very simple because every time you position yourself on a soft key, you highlight what you're going to do next. Let's pause. And let's move on to the second soft key, groove. Here too, groove. You have the standard groove, which I advise against using because it has sharp edges. The inclined groove that allows you to create a groove on an inclined surface, or the classic groove. What you see here has inclined sides, but you can decide whether to make them with parallel or inclined sides depending on your needs. You see that here you already find inserted the tool, a tool that is not present in the table, but is simply the last entry I made in a previous program. So, always selection tools, as you can see. There's nothing, and let's get into position. To selection, warehouse, which is the one you find below. You can choose a 4mm cutting tool or go to the tool list. New tool, and create a tool for the groove. Note that it separates the zeroed tool on the left from the zeroed tool on the right. I usually work with the zeroed tool on the left. Let's insert it. Here it is, the groove tool. Let's write down what its thickness is, 3mm, and let's insert the radius of the 2 points to allow the machine to compensate for it. To set the machine to enter the machine, to allow the machine to compensate for it. 02. The width of the insert changes as I move a tool. On the other hand, the width of the insert is 3 mm. The length of the insert is 10 mm. Perfect. Transfer to the cutting data program. And now let's get started. To worry about our groove, our processing, you can see that the groove is already inserted. It's done. More roughing though. You can also just rough it out, just finish it. So it enters, lifts, moves, and goes back in. Or you can rough it out and finish it normally. With the groove tools, you rough and finish X0. So you see that it measures the left point. Do you want to work with the right point? Just change this soft key. Do you want to make a groove for internal work? Just change this soft key. Obviously, it will give you an error if you don't go to change the tool. Because we've chosen a tool that will work externally. Perfect. So, we zero in on this point, meaning we start thinking from this point. The machine will then know where the tool is zeroed, and we will work on an external groove. X0. We said that our piece is 100 mm. So let's start working at 100 mm. Z minus 10. So this point here will be positioned at X100 Z minus 10, width in height of the groove line, and width. At the base of the groove, I want to give it the B2, I give it the width first to the left, and you see that it allows me, depending on how the designer, it was expressed in the measurement to use the B2. We'll also make it 10 mm wide. T1, the depth of the groove, or the diameter of the groove, or the depth. Sometimes they tell us that it's deep 5. Sometimes they tell us to reach a perfect diameter of 90, we make it deep. 10 mm. The alpha, you see, or alpha 1 and alpha 2. Is my groove angled? Yes or no? Let's say that one side is angled and the other is not. Then we have a chamfer at the entrance of 1 mm, a radius at the bottom of the groove, and we leave it with a radius of 1 mm, another radius at the bottom of the groove of 1 mm here, a radius or a chamfer on point 4, always 1 mm. I break the trick by going down. If I set it to 0, I don't break it. I work implanted if I set it to 1, 2, 3, or 4, every interval indicated in D. The plate will lift for a second and break the trick. Over metal in X and Z for the finishing number of grooves to repeat. For now, we'll leave it at 1, except it and simulate. Here we have made our groove. The groove, as you can see, is straight on one side and angled on the other. Let's go back to Edit, enter our operation, and tell it that I want 10 grooves. Now, perfect. A soft key opens up for me. 30, I will work to the right. Minus 30, I will work towards left. Minus 30, it's a bit too much. 10. Also, let's make 5 grooves. And let's give it a minus 20. Then he will make grooves spaced 20 mm apart. In the direction of our self-centering, let's accept and simulate. Here it makes the first, the second, and the finishing. Great. It's very easy to modify this program. In case a program variation comes in that says, no, I want both of them angled, I just need to do this, accept and simulate. You will see that our throats will both be angled. The sides of our groove will both be angled. Perfect. Let's go back to edit. In turning, sorry. So, edit. Let's delete. By trimming it, the operation is done. Let's go back to the previous block and return. In turning, you see the groove, it's draining. Well, the drainage should basically be done at the bottom. A shoulder. The concept, however, is always the same. We will enter our data to get a drainage. Let's do something nice. Let's go back to edit. Turning. Let's stop the roughing operation. Here it is. We have roughened to x50z, minus 150. Let's make z minus 50. We accept it. That's what we did at the beginning of the video. And you can see that our piece now has a chamfer, the chamfer that will need to be ground, and so down here it asks me for a grinding discharge. Now I'll tell you that dealing with all the discharges one by one will go crazy, but you see that if I go into discharge, I automatically have a whole series of discharges. The discharge for the bottom groove of the thread, the discharge following the DIM standards, the aft discharge, and the discharge. Let's start with the simplest one and do that discharge. And the concept is always the same. We need to first select a suitable tool. We don't have one here, so let's move to position 3 to select from the storage. And we're going to get a 35-degree finisher. We give it the OK and place it here. Well, in this case, I didn't bring it to a turret. If I'm making a mistake, it's because I didn't place it on a point. Tools. So let's go back to tool selection. Let's go to 3. Tool list. New tools. Let's do the same thing we did before. So we select a finisher, an external finisher. We give it the OK. And we tell it that it's a 35 degrees. So let's set the tool radius to 0.4. And the degrees of the insert tip. You see that it has become a 35 degrees. Let's transfer it to the program. A tenth at the gyro is fine, and we start to do the discharge on our shoulder. You see that I have an interior here, always due to the last operation done. Perfect. No, my discharge is an external discharge. Automatically, I can select a whole series of discharges, 0.4 and 4x5. And let's go get it. So, it's clearly visible. Now, the machine is asking me, give me the point where I will finish rounding. We have a depth. So, D is 0.5. Consequently, we have an outer diameter, and we set it to 49. Because our outer diameter is 50 meters. So the radial depth will be 0.5. Which is this point that you see highlighted, and this is my diameter, 50, the total depth. That's 0.5. And we give it to him. In fact, I made a mistake. 49.5. Because the depth, the diameter is 1 millimeter, but the radial is 0.5. 0, that is where the discharge will reach. We said that we created a roughing cut at a lower depth, 50. 0.5 step increment. Perfect. A VX. Where I want to face with the tool. If I want, I can face it all the way up to 100 millimeter. Let's see. Accept and let's simulate. You see how easy it is to create a grinding discharge. With, according to the standards, with ShopTurn. Let's go back to edit. Here I might have created a bit of confusion, and it should be for the radius of 4 me and 0.5 the depth. But what I was concerned about, it wasn't about making you great designers, but great programmers. And I've explained the concept to you. I'm not going back because otherwise we'll end up with a video that never finishes. Let's go back to turning. Let's exit from the last one. Tab we entered. Let's position ourselves after the program header, and now we have a thread. Good. Here too. First of all, you need to select the tool. Selecting the tool means, as always, going to our table. New tool. And let's choose an external thread cutter. Here too, we can make some adjustments. In the menu, okay. And you see that here we have fewer parameters to adhere to, because it just needs to think about threading. We will then be the ones to choose the correct insert. So we transfer to the program, and it's very simple here too. Do we want to use a table? Do we want to use an ISO table? Are we getting to M100? Let's see. We're not getting there, so having to thread on a diameter of 100, we work. Without a table, which goes to thread on a diameter of 100, let's do a diameter of 100, exaggerating a pitch of 4. Good. With each turn, our thread increases. No, our thread remains constant. At what speed do we want to thread? At 50 meters per minute. Machining, of course, roughing plus finishing in the thread is quite normal in turning. Work like this. Linear, a bit aggressively. So we want to enter first a bit more and then a bit less as we work. Or we can maintain the same depth of cut each time. Alright, starting point for the finishing, we said we have a diameter of 100 and we start at Z0. Z1. Thread length 50 mm. That's perfect. LV, safety distance, we have a step for at least 1.5 times the thread. LR, exit distance before the tool comes off. So we need to think about the quota. If we have a total useful thread length of 45 meter, here we can set it to a maximum of 5 mm. At the limit, 20 meter. 2.54 thread height, which is usually calculated automatically. Do you see it moving? All the other data is the depth, alpha, the thread angle that will determine it. The insert that we are going to use, or what we are going to write. Here, do you see that it tells me what to do? I go in all from one side, or do I go in all centrally? Do I go in all from one side, or do I go in first from one side, then from the other? That fits a bit with your needs. D1, the depth of cut. U, the excess material in finishing. Number of empty passes, that is usually done before finishing. You can make an empty pass to polish the tool or not. We don't allow it. VR, how much I pull away before coming back, I can do whatever I want. If I have doubts, I overdo it and pull away a bit more. I made a thread with more principles. No, I didn't make a thread with more principles. I made a thread with a traditional principle, so I accept and simulate. Here is our very nice thread. Okay? You see that you also see the detachment. Oh, of the piece. Perfect. Edit. All right. Let's remove the thread. And we go back to turning. Now we've made the thread. There remains the truncation, which is absolutely the operation. The simplest, first of all, selecting the tool. So let's go to the tool list here as well. New tool, let's look for a cutter or perhaps a groove tool or even a chamfer tool. Lathe tools, cutter. Here it is, and let's insert a cutter. Do you see that it has been inserted for me? Here's the cutter. I need to load it in position 5, which is the free position. That we have length, insert, in this case insert length. I will have to write at least 55, since I need to cut a diameter of 100 and a width of 2 mm. Let's transfer it to the program, and here too we'll provide all the necessary data. So, x0, stoimeter z, minus 10. Do we want to make a radius? No, I don't want to do that. I just want to cut it, plain and simple. But if I wanted to leave the piece slightly rounded, I can set it to 1. So, x1. x1 is where I end up cutting with these parameters, for example, at x10. F. A. These are the data with which I finish the cut to make it a bit smoother. x2 is where I go to cut. Why is that? Because as long as I'm working with the solid, I can work a bit faster. When I get to splitting the piece, I need to be a bit gentler. So we accept and simulate. So I block it, tool radius, too small. Let's take a look. Maybe I forgot to enter the tool radius. You see, I didn't enter it. Always enter the tool radius. Okay? Accept and simulate. Because otherwise it has a tool radius of 0. It can't do the compensation it needs to do in this case for this little piece. You see that we have cut our piece very simply. Edit. And we've addressed all of those that are the elements of the standardized turning soft key. Next time we will tackle one of these other topics, soft key or retacircuito. I hope this tutorial has been helpful to you as well. I'll be waiting for you for the next video. Don't forget to give it a like if you think it's appropriate. Thank you all and have a great day.